Well, I promised it, and here it is. Topic 7.06 Empirical Formulas. Last time when I showed you how to do percent composition, I gave you a little bit of a teaser of what's going to come today. How exactly do they experimentally determine the formula of a substance in the first place? I mean, again, you can't just ask a substance what its formula is. You actually have to do some lab work in order to make it happen. The empirical formula, which is the formula used for ionic compounds, is the smallest whole number mole ratio of the elements in a compound. And the definition gives away the game in terms of how to calculate it. First of all, it's a mole ratio. So you have to make sure that all numerical values represent moles. Second, it has to be a whole number ratio, no decimals. And finally, it cannot be able to be simplified. It is the smallest whole number mole ratio of the elements in the compound. So, how do we achieve all of this? Well, first we have to take the amount of each element we have and convert it into moles. So what we do is we divide the given mass of each element by the element's atomic mass, and this will give us what we're looking for. And I have to yahoo sneeze. Then get the smallest whole number ratio by dividing all of the mole amounts by the smallest mole amount. Or as I like to say, convert to moles, divide by small, double if needed, empirical. So let's suppose we have a compound and we decompose it, and it contains 10.7 grams of magnesium, 5.28 grams of carbon, and 21.2 grams of oxygen. What would the empirical formula of the compound be? So convert to moles. What we'll do is we're going to convert all of them to moles. We're going to list each element to make keeping track of everything easier. This is the number of grams of each element there is. We're going to divide each by the atomic masses given on the periodic table. 24.3 for magnesium, 12.0 for carbon, and 16.0 for oxygen. This will give us a mole ratio. And remember to round to sig figs. Remember 333, 333, 433. So we have a mole ratio, but it is not a whole number mole ratio. So even though we have convert to moles, next we have to divide by small. So which of these three values is the smallest? Well, that goes to 0.440. So we're going to divide all of these values by 0.440. Dividing a number by itself guarantees that you're going to have one. You can't simplify one any further. And any other numbers will either come out to be really close to a whole number or really close to something 0.5. Well, if it comes out really close to a whole number, you just leave it as a whole number. The formula is MgCO3. So again, we convert to moles, divide by small, and then what we got is empirical. Now, remember what I said is if it comes out to near a whole number, then just round to the whole number. What if it comes out to something 0.5? Well, that's where the last line of the song, double if needed, comes in. So let me show you an example of how that works. We decompose a compound. We find it contains 43.7% phosphorus by mass and 53.3% oxygen by mass. What is the empirical formula of this compound? So once again, we will just write the symbols so that we can keep track of it and write the percents. Percent. How do you convert percent to moles? Well, it's easy. Assume that you have 100 grams of compound. Because what 43.7% means is that out of every 100 grams, 43.7 of them are phosphorus. So if we're assuming a sample size of 100 grams, we can simply change our percent signs to gram signs and then proceed as normal. Convert to moles, so we'll divide them by their atomic masses. 31.0 for phosphorus, 16.0 for oxygen. That will give us a mole ratio. Convert to moles, divide by small. Since 1.41 is the smaller value, we'll divide them both by that so that the smaller value will come out to 1 and the second one comes out to something 0.5. Now, a simplest whole number ratio does not have to be a 1 to something ratio. It can be an odd number to even number ratio or an even number to odd number ratio. So if we get something 0.5 for our mole value, that means it's not a 1 to something ratio, it's a 2 to something ratio. So what you do is double if needed. So we're going to double both values. A 1 to 2.5 ratio is a 2 to 5 ratio. And therefore the formula is P2O5. Convert to moles, divide by small, double if needed, empirical, yada da 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 dum da dum. So if we go back to the beginning, let's go back to the beginning. Once again, we're going to take our grams, convert to moles by dividing by the atomic masses. Grams will cancel and give us a mole ratio. We'll divide by the smallest of the mole amounts. This means the smallest mole amount will come out to be 1. The other mole amount comes out to something 0.5, which means it's not a 1 to something ratio, it's a 2 to something ratio. Double them both and you get a 2 to 5 ratio. That is all there is to figuring out the empirical formula. That's it. No matter what problem they throw at you, it's done exactly the same way. Convert to moles, divide by small, double if needed, empirical. Yup. Bum 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 ba-da.